Hello and welcome.
Good afternoon.
Hope you had a good weekend.
Never long enough.
Right? I have the same issue. Good thing Labor Day is coming up.
Indeed. Do we have meeting notes for this call yet?
Oh yeah. So I need to I'm gonna reuse the same ones as last time, but I need to get you added.
Okay.
We have to let me put this in chat. There was an issue where we had the Google Docs open to anybody.
Mm-hmm.
And an external security researcher reached out and said, I could edit your doc and add in a malicious link. So we tightened it down, and now we need to add people back manually. So, and let's see here, share.
Can you do it with crob560@gmail.com?
crob560@gmail.com. Let's see here. CROB.
Since we're technically not allowed to use Google Docs at work here.
Gotcha. I am sending that to you
Groovy.
right now.
Thank you.
Absolutely. So we had the and I'm going to need to update this with a new spot for today's meeting. Doing a little bit of live, but I am ready to share, I guess, a first draft of a reference implementation for this technical meeting. Let me share my screen. It's going to be screen 2. So, so here we go. Looks like it's just us 4 today. So welcome, Joe, Jasmine, and Crobe. I'm sure we'll have some others trickling in here soon.
Good afternoon.
Hey. Joe, would you like to introduce yourself?
Sure. My name is Joe Bussell. I am lead in the Windows engineering system. And my interest has been on driving supply chain trust for primarily the Windows build tools, but then the Windows product all up.
Thank you. And does anybody else want to introduce themselves? Or I think I'm recognizing everybody here was here last time. All right, great. So the topic for today, and I should also capture this. And post it here. The topic for today is first pass at a reference implementation on GitHub. So, and I've got this doc here. And so let me walk through. So I wanted to take a first stab at how a GitHub project would what they could do with the existing controls and existing open source available that they have to integrate to meet some of these controls. As we go through these, it's important to note that some of these are, done out of band. They're not done in the configuration of your repo or anything like that. Additionally, things like where is it? Additionally, there are things that we'll get to as we go through one by one that are like out of band processes that could be done by an organization, but not necessarily just a single repo. This was originally, designed with large teams in mind that are consuming, open source, and so putting a lens on an open source repo actually was refreshing in many respects. So let's walk through. And by the way, do I need to zoom in? Is this good for everybody? I zoomed in anyways. Way too much.
Way too much, man.
Okay. So use package managers trusted by your organization. This is like, hey, let's make sure we always pull NuGet packages from NuGet.org instead of mygit.com. So it depends on what project you are and where you would want to be pulling from, but you would define those up front. As a participant in this, you'd say we only want to pull packages from these kinds of locations. With Linux as well, that also becomes very because there's so many different repositories out there. Again, with the focus that this is a GitHub open source repo, use a binary repository manager solution. So GitHub packages can cache artifacts such as container images, as well as npm, NuGet, Ruby, and something else. I can't remember the full list. And this would be there to protect you from, you make sure you always have a package cached locally in case the upstream ever goes away. So having a deny list capability to block malicious OSS, this is actually really interesting because there have been requests, I've seen like GitHub issues filed on various systems to say, can I please have control over what I block from being installed? And so this hasn't been a capability that's been implemented by any of these package manager solutions. However, you could effectively manage your own deny list through the dependency review action in GitHub. You first create a branch protection rule for your default branch, and you select require status checks to pass before merging. And if a component has a vulnerability, this part of the build will fail. And one of the wonderful things that GitHub does is it now auto creates CVEs for malicious components. This was mentioned in a blog announcement a few months ago. And the biggest reason why you want to have a deny list is to block these known malicious things, just on the off chance that they do get consumed after the fact. And so now that GitHub is auto creating CVEs for known malware, this in effect becomes your deny list capability. And so here's the documentation on blocking pull requests. By the way, feel free to jump in if anybody has any other thoughts or alternatives that they'd like to suggest. Happy to be interrupted. So ING4, this is, mirror a copy of all OSS source code to an internal location. The whole point of this was, hey, for native code, you want to be able to store it locally, just like you do with caching a binary. You want to be able to continue to build even if the upstream goes away. Even if you're not using native code, and let's say you're using Python or JavaScript, using this framework, you would still want to copy all of that source code, because in the event that the code gets removed or the package gets removed, if this is a critical dependency, you want to be able to take ownership of that code and continue to move forward. If it's a dependency that you could easily switch away from, then maybe it's not so important to you or your team or your company to mirror all of the source code to an internal location. But for critical components, this is recommended. And so there's guidance here on how to do this, but again, this isn't something that you would do on a single GitHub project. Hi, Johnson. Thanks for joining. We're just going through an example reference implementation for a GitHub project, and feel free to jump in with other suggestions or anything. So scanning OSS for known vulnerabilities. This is level 1. This is pretty basic, and this is built into the dependency graph in GitHub. If you are an open source project, you get this capability for free. If you're in GitHub Enterprise, this comes with your purchase of GitHub Advanced Security. Scan OSS for licenses. This is also done through configuring dependency review. And so it's provided to you through the Insights tab when you're looking at your organization and all of the packages that are consumed across your entire GitHub org. Scan OSS to determine if it's end of life.
I would love, where do I get a hold of that scorecard?
Right? Okay.
I need that.
I wanted to talk about this because the data is here. The OpenSSF scorecard does have a way to determine if something is end of life. I believe that's one of its markers. Michael Scavetta, please correct me if I'm mistaken. But this
I think it's more of is it actively maintained, not is it affirmatively end of life. I might be wrong there, but I thought it was just a, if you don't see a commit in 4 years, you can infer end of life.
I think it's more commitment activity, not end of life.
Got it.
Oh, okay. So there are some things we know, like we had an Azure Storage API that I had to remove from one of my tools. And I found out about that dependency late because there's no great place for me to just one-stop shop. Hey, here's all my dependencies. Which of these are now deprecated?
It depends on the project. They might publish it as an advisory. They might put it as a blog entry. They could put it on a mailing list. If they're good, they would put it inside their security policy MD file. They would describe kind of what their support expectations are. But yeah, it's not consistent.
This is a great area for, I think, cross-company collaboration to come up with a solution that would actually be a data contract we would all love.
Yes.
Yep. The Security Insights project that Luigi was running, one of the reasons for that was to have a structured way of finding out these things. Obviously, folks need to use it in order for it to be any value, but that would be at least be a way of not squirreling it away inside of a block of text in the README file, and something that you could discover if it were there.
Is there a link that you could share, Michael, with me offline?
Yes, I will later in this. I'll reply or add it to the notes.
No, that's fine. No, not a hurry.
Cool.
All right, I put a note about security insights, assuming that that's different than this OpenSSF scorecard. I'd absolutely love to review that. So OpenSSF package analysis. If this loads quickly. Package analysis does, it's redirecting, but it does say that it can detect malicious OSS components. And there are not a whole lot of free tools out there that can do this. Here we go. Malware analysis results. And so coming up with a way to, so this subscribes to this package feeds project. And I personally haven't implemented this myself, so this might be a pet project for me to test this out. But Michael, do you have your hand raised? I see a box around your screen.
Working at all? Sorry, I'm switching. God knows what it's doing. Sorry.
Okay, no worries. So testing out how to integrate this to leverage the OSS malware analysis results against the OSS that you're using is going to be the next step to make sure that this is feasible. This is kind of my first step here. I think Mend has a plugin that does OSS malware analysis, but it only supports like 2 ecosystems. So that would be like an optional second thing to add that's also free to implement. So this is follow up on implementation instructions. Next is perform proactive security review of open source. This is where proactive security scans will likely be done out of band from a build. So, so usually this is prior to using something, you do some sort of a security review assessment to determine to check it for other things other than known vulnerabilities. So this is kind of like looking for backdoors and those sorts of things, but this isn't something that gets integrated into your your build pipeline. So I've just kind of noted that this is usually done out of scope of your build, and it's usually done like if you've cloned the source. Maintain an automated inventory. GitHub dependency graph does that for you. And then, having an OSS incident response plan, of course, you would write one. There are lots of different incident response templates out there that you could leverage. But ultimately, it needs to be focused on how to roll back versions of OSS. The assumption here is a bad actor has compromised a given package. That given package is usually the newest version of that package. And so if you have auto updated, for example, you would want to have your incident response plan be able to identify, are you using the thing, and then steps for yourself on how to roll back versions. So I had this in here because, level 1 is supposed to represent a majority of what everybody does today. Everybody already updates their OSS when they get around to it. So this one's kind of like a given. It's a gimme, like if you're playing bingo and they give you a free spot, like that's what this is.
Well, it sort of suggests that you're actually updating those vulnerabilities manually as opposed to you can.
True. You have to actually have updated your vulnerabilities in order to claim compliance here. The enable automated OSS updates. This is where I'd be recommending Dependabot. It's built into GitHub, so you can leverage that technology. And if you didn't want Dependabot, there's that other one called something bot, and it starts with an R. All these bots get
Does
me.
Dependabot know about deprecated dependencies, or only ones that are like have incidents against them, or have been just straight updates?
Just straight updates. And it has to be a vulnerability in the GitHub vulnerability database, I believe. I can double check that last fact, but I think that's true.
I could dig. You don't have to dig for me. I was just curious.
Okay. And
Adrian, the bot you were thinking about, I think
Renovate bot. Yes. Thank you. There's a gazillion bots out there, and so okay, and then and so both of these, or I'm sorry, update 2 and update 3 are very important to helping organizations patch their known vulnerabilities faster. This one automates it for you and sends you a PR. This one will display vulnerabilities as a comment in a pull request. So if you have 2-person PR review enabled, then if a contributor submits a pull request that contains a vulnerable dependency, it will raise that as an issue as a comment in the pull request. And the reviewer will see those comments and will more than likely not want to accept the PR, and will ask the person to go back and address those things before that all gets merged in. And so that's the whole idea. It's shifting everything left. We're not introducing anything bad anymore. Then, and so dependency review is the other thing that allows you to have that capability built right into GitHub. Verify the provenance of your OSS. So different people describe or define provenance in different ways. And so this is one of those things that I think I could probably do a better job at improving the definition of provenance, like what is actually being verified, before I come up with a recommended solution here.
For a GitHub repo, what I want is the repo that it came from and the commit hash from whence it came. That's provenance to me, but I definitely think that there are other answers that could come from a non-Git type of repository.
Oh, this is like the Git bomb project, I think.
This is the provenance that we have in our open source SBOM tool, actually, right?
Right. So we can decide upon this. So one of the great things about the OpenSSF is it's got this 10 work stream mobilization plan, and one of those work streams is the SBOM Everywhere initiative. I'm personally really excited about that. I've spent a great deal of my time working with SBOMs, so I can't wait for them to be more ubiquitous across the board. So I have an action to kind of come back and come up with a better recommendation here based on a definition of provenance that we can all agree on.
Where you say hash from whence it came, just to be correct, if you don't mind putting commit hash.
Oh yeah, thanks. I totally missed that. I don't know what happened. So audit that developers are consuming OSS through the approved ingestion method. If you have a GitHub project, you really only need to look at all of the repos that make up your GitHub project. So the scope of auditing isn't that great. When you get inside of a maybe like a large company that wants to be able to do this becomes harder. And the idea is you're trying to secure your supply chain, so you need to control all the inputs of how open source is being consumed into a build. And if you can control the inputs, then you can have the open source be evaluated through your measures, like vulnerability scanning, inventory, and malware scanning. But if you've got your malware scanning configured and it can check only a certain amount of things, you want all of your OSS to be consumed through this governed workflow. You don't want people using wget and curl and everything else to consume the open source through some other means that's not a governed workflow. And that's what this is all about. So there's actually opportunities here to automate detection of ungoverned OSS, and the tool that you want to use to do that auditing depends on how you are choosing to force or enforce your secure consumption flow. So I don't have a tool to recommend here.
Let's ground this one out on an example. I think we've all seen examples where we've had to nudge someone, hey, that looks familiar, where they've introduced some open source piece, something they found on Slack, Stack Overflow or whatever, and they've introduced actual open source into code, right? So do we have like an index methodology to address that basic pass where we can identify the open source is in fact in the source code undeclared? namely, I implemented log4j in my own my library dot, DLL, right? And can see clearly that same, operation is there. We have cool tools here at Microsoft. I don't know what we have for in the open source community for doing that kind of work.
I'm not aware of any good open source or kind of common methods for doing that. I am optimistic that the future of SigStore will have, and probably maybe GitBomb as well, will have essentially artifact lookup by file hash. So if you took a bunch of files from log4j, renamed them, or maybe didn't rename all of them, you in the future you should the capability should be there. If you're just copying a couple lines of code from Stack Overflow, good luck to you. You need to kind of index the world and then look it up. But that's hard.
Yeah, it is hard. I know that, within Microsoft, there's a few certain, I'll call them an anti-pattern that we're looking for. And as we build out tooling to help us identify those at scale, we'll look into open sourcing those tools. No promises, but that's the intention, is to make these tools available to others that have the same problem, and hopefully they can help at least identify specific scenarios.
I will say, just kind of anecdotally, just searching for copyright and not your company name is really effective in ferreting these things out of large code bases. So, there probably is a 80-20 rule in getting good enough. That's straightforward.
Yeah. Validate the integrity of the OSS that you consume into your build. This is usually performed by the language package client. So like with npm or NuGet exe, these are usually done during the install. I would have to go in and check if there's any client out there that doesn't do this natively by default. And if this is kind of handled natively by default across the board, then I might want to reduce this to like level 1 or something. However, with things like SigStore and other signing technologies that become easier for the open source community to take advantage of, there may be future tooling required to be validating those signatures. Validate the SBOMs of the OSS that you consume into your build. So this is a level 4 item. Level 4 is largely aspirational in nature, and this is kind of like assuming a world where, if you do consume some open source into your build that comes with an SBOM, you can leverage that SBOM to double check the identity or the provenance, et cetera, et cetera.
You're probably going to want to tighten up your word validate and be more descriptive. Are you checking that they made one, that it is the correct hashed value you expect it to be? Or are you actually going through and checking it against something like Vex for vulnerabilities? And the same thing with integrity above. Are you looking to see, is the package corrupt? Integrity from an information security perspective has a little bit different meaning. So try to define above like what you mean for integrity.
Okay. By the way, I'm not sure where's the chat? Okay, things are being sent in chat. Let me, I'm putting this in here in case folks didn't already get this link to the stock. Okay, and you were saying, Krav, that validate integrity is.
Are you just checking that it's the same file that you expected when you downloaded and it hasn't been tampered with or corrupted? You kind of maybe explain what you're validating. You should be a little more descriptive.
Okay. Happy to. Thank you for that feedback. Okay, so enforce. So this is, there are two requirements here in the enforcement practice. And the idea behind enforcement is these are things that are dangerous enough that are worth breaking your build for, or some other type of enforcement that stops the bad activity from progressing forward. Securely configuring your package source file is all about the dependency confusion attack that happened a year ago. And if you are a team that's using a dependency config file and you pull from multiple different sources, like a public source like nougat.org, plus an internal feed source, and you're combining private packages with public packages, it's possible that your client just calls all feeds simultaneously and says whoever responds first wins. And that's how the dependency confusion attacker can have their external malicious package with the same name but higher version be fed to your feed instead of your intended internal only version. And so you should follow. So this was a guide that we ended up publishing as a result of that that announcement of that new technique on ways to mitigate this. And so these are certain configuration things that you can do depending on what ecosystem you're in to tighten down your config. For enforcement level 2, this is making sure you enforce usage of your curated open source feed. So if you think about all the requirements that we've gone through already, you've made sure that you are consuming from the proper upstream place. You have your packages cached locally and that you're pulling from your local cached things. You're scanning all of those things for open source. You're getting an inventory of all of those things. And we're also scanning all of them for malware because that is our approved consumption flow. And because all of these things are detected by our inventory tool, we're able to benefit from all of these automated and better updating capabilities. So when we come down here, we really need to enforce the usage of that consumption flow. So an example of how to do that is to apply branch protection. So if the thing that we care about the most is make sure that this OpenSSF package analysis malware scan is being run every time we do a build, then you can create a branch policy rule that says, make sure that this was run. If it was run, then you can allow the merge. And so that's a way to enforce this for your GitHub project. Then all the remainder here are all kind of level 4. And so they don't, I didn't describe anything here about a reference implementation for these. I wanted to make sure that we could hit level 3. And
Adrian, on the previous one, is that
Sure.
where you think Vex comes in as well? Or do you think it's going to have its own bullet item?
so yeah, this can get more complex over time. The idea is if we always have our ingestion gates, for lack of a better term, validating the sources that we're bringing in, and they have to come through this path in order for all of these checks and security capabilities to run. Whatever that path is, that's the thing we need to enforce. We need to enforce that all OSS is coming through that path. And if it's being consumed outside that path, then that's bad. So yeah, Vex could be added to this list. So with rebuild the OSS in a trusted build environment, again, this framework is not describing the requirements for what a trusted build environment should be. That's a prerequisite. But these level 4 items are reserved for the most sophisticated attacks, such as build time attacks, where nation state actors obtain a presence on the build machine and are manipulating code as the software is being built, and so they're silently contributing their malware or backdoor to the piece of code. And that is where you would want to either have a reproducibly built binary, I'm sorry, for OSS, you would want to be consuming something that can be reproducibly built, or you could potentially rebuild these things yourself. And again, this is kind of like, if it meets your criteria for your company or your team, that this is a critical component that must be secured beyond these normal risk reduction activities, then these are the extra measures that you can take to make sure that you can trust these critical components in your software.
We did spend most of the time talking about open source dependencies. I think that's completely appropriate. There are some subtle cases where open source tools can come into play. I'm wondering if there's going to be any comment here in this around validating those open source tools.
Oh, in vetting the tools themselves?
Hey,
It's like trusting
Microsoft came up.
trust.
Yeah, Microsoft give you this cool SBOM builder that's open source. We think it's cool, but do you think it's cool? How do you vet your tools that you're going to use in your pipeline?
Perhaps it'd be better to state vet or validate tools included into your pipeline. That way, that would account for both closed and open source.
I like that. But it just feels like its own L4 thing, I think, is kind of what I'm saying.
Yeah, you're right. That's a good point. That's something we could consider adding.
You also can provide a reference implementation of what a secure or trusted build environment might look like. Whether it's air gapped, access controlled, heavily monitored, whatever those controls you put in place are.
Yeah. I don't know if that's a one of, it's a sliding scale.
Correct. But you might want to provide that as a an exemplar.
Yeah, we definitely have some thoughts about that, and what we're working on. I know Salsa also has their own list for build integrity. Yeah, that's a good thing we could put on the to-do list. I think this meeting has reached its end. I think this was a 45-minute. Does anybody have? Oh, Crob.
I have
Yeah.
one point for you. When you're
Yeah.
done with this exercise, and my friend Xavier from the GitHub Security Labs would echo me, but you need to also provide other repositories as reference architectures. GitLab, generic Git, other. Because Xavier is one of the most fierce reminders that we need to be neutral if you're working with an open source ecosystem. While GitHub is very popular, it is not the only.
That makes a lot of sense. You said GitLabs, and what was the other one?
Just generic Git.
Just-
You have
oh.
things like there's a bunch of different different tools.
There's Maven and a whole bunch of package managers. I don't treat them all as unique or distinct. They all have to have the same capability.
Okay.
Hey, Adrian, we can go the full hour. This is so remember before we were just restricted to 40-45 minutes because we were using Zoom locally, but since we've gotten some good Zoom links from the OpenSSF, we can take the full hour if
Right.
required. Otherwise, if there's nothing else, we could move on.
Yeah. The thanks for the reminder, Jay. On my calendar, it's only 45 minutes, and somebody chose to schedule a 15-minute meeting with me right now. So I have to jump. Any other final thoughts?
And it wasn't.
And it wasn't Roy. Yes.
When were you folks thinking about potentially approaching the best practices group to talk with them about further collaboration?
Actually, Crub, we were waiting on you. I think at last meeting it was you would pull to orchestrate us getting in front of all three. I think the best practices, the end users groups together, pulling those groups together so that we could just do one presentation to all three. I think it was best practices. I think it was end users. And I want to say the education's sake for some reason, but I can't remember that.
That'll be a challenge since we all have pretty distinct schedules, but I will do my best. The best practices group, and why I asked, is we're meeting tomorrow. And we had some time on the docket before we start our backlog triage. If you wanted to optimize.
I think let me check the calendar there, Adrian. You know what? Why don't we do this? After we get off the call, Adrian and I will check the calendar, see if we can make that jive. I'm good to go.
Or shoot me a note with the other groups aside from end user, if you remember what the third one was, and I'll try to start a thread and include you gentlemen on that to see if we can get a doodle of when that might all.
Fantastic. Thanks, Crob.
Welcome.
Okay, I will see you all later. Have a great day.